Question 4. Predict the result of mixing reasonably concentrated solutions of the following ionic compounds. If precipitation is expected, write a balanced net ionic equation for the reaction. So what I kind of did was I went ahead and I wrote down the potassium sulfate and barium nitrate, the lithium chloride and silver acetate, and the lead nitrate and ammonium carbonate reactions. What it comes down to is after you write down these reactions, which I expect you to kind of either know how to do or you're starting to figure it out. I just really didn't want to go through explaining each, reaction. What it comes down to is learning what is soluble and what is insoluble. I know that's a little tricky and it can be a little confusing because when you find out it's insoluble, you immediately label the compound as a solid with the variable S. I always used to get confused by that, but it's really just understanding your solubility rules. For instance, I know for A that the sulfate right here, because it is attached to barium, that makes it, I'm going to change my pen. That makes it solid. I know that chlorine, it is a halogen, and halogens are usually soluble, except when they have a silver, or one of the other different exceptions. But because it has a silver and it's a halogen, I know that this is also insoluble, therefore it's a solid. And lastly, I know that carbonates are always solid unless they have a group 1A atom or element. So I know that this is also solid. So all three of our reactions have a precipitate, which means they're all going to have a precipitation reaction. So what I'm going to do is just like with number 2, I labeled our ionic and ionic in different colors. I'm going to stick to those colors, and I'm going to say that technically this is our molecular. I'm just going to put an M. I'm going to say that our ionic, and I'm just going to put I, is going to be this one. Our ionic, I'm going to put K2 plus SO4, which I know SO4 is -2, which means that this K2 technically needs to be +1, because 2 of these ions make it +2. For me, I'm just going to put +1 so then I don't get confused. I know that we have our barium, which is actually a +2 ion, which is why our NO3 has 2, because it's a -1. I'm going to put these in parentheses and put a 2. All of these are aqueous. I'm going to label them all as aqueous. I know it's a little messy. My handwriting, forgive me. I hope you guys can see it, like, kind of clearer. But that's how we would put all of our reactant side. Then we'd know our barium sulfate is a solid, so we don't have to break it up, plus our 2K, which is also +1, plus our 2NO3, which is -1. Don't forget the aqueous. I am going to say these technically could be gaseous or they could be aqueous. I'm going to keep them as aqueous because, as we said before, we can't cross out different states. Aqueous just means it's in a liquid form, but gaseous means it's in a gaseous form. Anyway, I'm getting too lost in the sauce. Now we can cross out our potassiums, and we can cross out our nitrates. So now what we're left with, and I'm going to put N for net ionic, is we're left with I'm going to put our barium in front of our sulfide just for consistency of, how we write it down. So I'm going to write Ba plus 2 aqueous plus SO4 aqueous. This is -2. Gives us our barium sulfate solid. And so then we just continue to do that with our other three equations. We're going to have lithium. I'm going to put our I right here. We know that lithium is going to have, I believe, a +1. I'm going to say it's aqueous. Plus our chlorine, which is a -1. That's going to be aqueous. We have silver, Ag. And I believe acetate is a, so acetate, I believe, is a -3 charge. Let me look that up because I could be lying to you and I don't want to do that. It has a -1 charge, so our silver is +1. I don't know why I forgot silver was +1. Oh my gosh. It's late at night, guys. CH3, COO is a -1 aqueous. Then we're just going to, say our silver chloride, which is solid. And then we're going to put our lithium, capital, aqueous. That's going to be a +1. Plus our CH3, COO, and it's going to be a -1 charge, and we're going to keep it as aqueous so we can cancel everything out. So we know we can cancel out our lithium, and we can cancel out our acetate, which that leaves us, and again, for the sake of consistency, I'm going to put N right here to mark our net ionic. Silver +1, aqueous, plus our chlorine. I keep trying to say chloride, and it's not what I mean. Gives us our silver chloride solid. And last, but certainly not least, we're going to talk about our lead nitrate. I'm going to break it up. IPB, aqueous. Again, it's really just a lot of writing down aqueous. I'm going to say that this is a +2, plus our NO3, 2, -1, aqueous. You kind of get into the habit of writing aqueous down a whole bunch of times. Oh my goodness. Sorry. NH4, 2. This is going to have a +1 charge, but there's going to be 2 of them. Aqueous. Plus our CO3, which is a -2. Aqueous. Which then we get our lead carbonate solid. I'm running out of room here. 2NH4 aqueous +1 +2 NO3 aqueous -1. So then we can go back and look at our full thing. We can cross out our nitrate and our ammonium. And again, for the sake of consistency, actually, this case, it actually has the lead in front. So it's going to be PB +2 aqueous plus our CO3 -2 aqueous goes to our lead carbonate solid. And I want, after, finishing this problem, I want us to notice that our charges every single time balance out to 0. So 2 minus 2, 1 minus 1, and 2 minus 2. And that's another thing to kind of check to make sure that your net ionic equation or your net ionic reaction is actually a feasible reaction.